Chapter 5, Section 2 is all about extrema. And extrema just means extreme values, that is, the highest and lowest points. Some functions have an absolute extreme. For example, this one has an absolute max because it has a highest point where no other point would be higher. Whereas a curve like this would have an absolute minimum because it has a lowest point where no other point is lower. Some functions have what we call relative or local extrema. So in other words, this is a high point within a range, but it's not the absolute high point because the curve continues this way. And the same for this. This is a low point within a certain range or interval, but the function continues downward here, so it's not an absolute, it's just a local. Or the word relative is also used for local. So let's answer some of these questions about extrema. Find the locations and values of all relative extrema for the function. Now, one other thing I should mention. There's a point at which the extreme occurs. That's going to be an x value. The actual extreme, though, is the function value or the y value. Okay? So once you find the x value of the extreme point, you must put it into the function to find the y value, which is the actual extreme value. X is just where it occurs at. F of x is what it actually is. So for this function, you can see that it has a local high point or maximum of, that's the y value, 1, at the point x equals 4. Here we see one that has multiple low points and a single high point. That's not the absolute because these arrows say it continues onward in the upward direction. But this function has a, look, of 0. Look, not at 0. That would be the most common mistake, is to say at 0 it's between 1200 and I guess that means 1296. So the zeros here, that's the y value when you're on the x-axis. So those are local minimums or relative minimums at two different values of x, -6, and they ask for a comma between +6. It has a, look, 1296 is a high point, so that's a relative maximum, and that's where x is 0. Suppose the graph below is the graph of f prime of x. Now don't be confused. This is the derivative of f of x. Find the locations of all relative extrema and tell whether each extrema is a relative maximum or minimum. Now remember that the derivative is telling you how the function is changing. If f prime of x is less than 0, the function is decreasing or falling. If f prime of x is equal to 0, it's constant, not changing. And you're going to find out that that's also going to be an extrema at the point where it's 0. And you'll see that in a minute. If f prime of x is greater than 0, we've got an increasing function, so it's rising. So this graph tells us what's happening to the function. So let's put our values on a number line where it's 0. So here's where the derivative is 0. It's 0 at 3 and at 7. Now to the left of 3, it's a positive value. That means the function is increasing here. Between 3 and 7, it's negative. So the original function is decreasing. And from 7 on, the derivative is positive, so the function is increasing again. So let's draw just a quick sketch of the graph. It's increasing till it gets to 3, where it's constant for a second, and then it starts to fall, where it's constant for a second, and then it starts to climb. So the original function looks something like that. So what do we have? We have a local max, or a relative max. We have a relative minimum here. So the function has a relative maximum at x equals 3 and a relative minimum at x equals 7. Now this time they don't give us the derivative of the function. They give us the function and they want us to use the derivative to help us find the extrema. So we've got f of x equals negative x squared minus 5x plus 2. Now, if you remember from your algebra days, this is going to be a parabola that's upside down. All right, so let's see if we can see why. Let's do our derivative. F prime of x is negative 2x subtract 5. We set that equal to 0. Minus 2x is going to be equal to 5. And x is equal to negative 5 halves, or negative 2.5. We put that on our number line. I'm just going to write it as negative 2.5. Now remember that my math lab always wants a fraction, but it makes it easier for you to make sure that you're picking values that are actually to the left and to the right of your 0. So we're going to put 0 into the derivative. If I put 0 into negative 2 times 0 minus 5, it's going to be negative on this side. So the function's falling over here. The original function is. And if I put negative 3 in, I get negative 2 times negative 3, which is 6 minus 5, which is positive 1. So it's positive on this side, and it's rising or increasing over here. Now, if a function is rising until it gets to here, and then falling afterwards, this has to be a relative maximum. And in the case of a quadratic, it's going to be an absolute maximum. And I always say relative or local, those words are interchangeable. So it has a relative maximum but no minimum. So there are no relative minimum. The function has a relative maximum of. Now look, we don't know what it is yet. We know that at negative 5 over 2, it has a maximum. But we've got to go back to our original function up here. And in that original function, we've got to put the place where it's having a local extrema, or a relative extrema. So we've got to do f of negative 5 halves, not f prime. We know what f prime of negative 5 halves is. It's 0. So we're going to do a little fraction arithmetic here. Now you got to be careful here because there's a negative here. So there's going to be a negative and a negative 5 over 2 squared minus 5 and a negative 5 over 2 and a plus 2. So this is kind of tricky. Look, you've got a positive when you square it, but this is actually going to be negative 25 over 4 because this sign is not affected by this exponent. This is a positive, but once we do 25 over 4, we have to take the negative or the opposite of it. plus 25 over 2, and then plus 2. And of course, we have to get a common denominator to add fractions. Use your calculator if you have to, but look, we just need to multiply this one by 2 and this one top and bottom by 4. We want a common denominator of 4 so we can add our fractions. So negative 25 over 4 plus 50 over 4 plus 8 over 4. And that's going to give me 25 over 4 plus 8, 33 over 4. So that's my actual maximum value that occurs at the x value of negative 5